Welcome. It's a pleasure to be here. I'm working for 4titoo. 4titoo is a company. We've developed a software platform that uses eye tracking, gesture, and speech input to control everyday devices. To develop that, we actually use Qt more or less completely. One of the main reasons for doing that is because we want to have the portability across platforms. Currently, what I'm going to show to you today is mainly available on Windows, so I'm sorry for those who don't use Windows, sometimes me. So what I want to talk about today is really the question, how can we use next generation sensors to control devices and then 3D environments in the future? And to get those of you started who have not worked with eye tracking, I'm going to do a little summary on why you should consider it. Quite fast, actually, and what are some of the challenges you will face when you do that. So first thing, why should we consider it? I mean, we have the keyboard, we've got the mouse. Basically, they all ignore our strengths. One of the strengths humans have, and one of the things those of you who have kids will know that, is pointing. When we are 1 year old, we start pointing, and kids will pretty soon tell you what they want. That's one of the natural things we have in our brains. Next thing is speech. Humans speak at around about 160 words per minute. They can think at around about 400 words per minute. So while I'm talking to you, you will have a second stream of thoughts, thinking about other things or combining things I'm talking about. The moment we start typing, we go down to something around 33 words per minute, which is clearly the point where your thoughts don't get into the machine as fast as you have them. Now combining that is the moment we go into a world of IoT where every lamp here would be controllable, or we go into a world of VR and AR where you have a 3D environment to interact with. The fastest way to address something is turn this lamp off. Everybody will know what's meant. A computer has no idea today because it's got no idea of what you're doing, where you're pointing at, and what you're saying. And the thing I'm going to focus on today is really the topic of eye tracking, which is very interesting. You will analyze things at around about 13 milliseconds per item. The moment you walk into a room, you look at something, and within 13 seconds, you have a rough idea of what this is. So this is not meant as an input device usually, but the interesting thing is the things you focus on tell us, with the New Year framework, something about what you want, what you're thinking about, what you want to do. The second reason, or the main reason why this becomes relevant now is really because the technology is getting there. These sensors, this is an external eye tracker, costs 100 euros now, $100. 5 years ago, you would have paid $10,000 to do that, so that was no point. But now, this year, actually, we have seen the first eye trackers integrated into laptops. So based on that, you will be able to use that in designs you're thinking about in the future. And another point is, as I mentioned before, VR and AR. That is something where eye tracking comes very naturally. First of all, because you have a very controlled environment, so it's very easy to integrate eye tracking. It's a lot easier to put it into glasses rather than using it on the distance of 1 meter when you work with a laptop. Second point is, and that is that's the reason why it is already coming, and we expect it to be in more or less every second generation design of headsets, is the fact that it saves you resources. Knowing where somebody looks allows you not to render the rest of the interface. So that's one of the reasons why all the manufacturers are putting that into headsets or are considering it. And the third aspect is, as I mentioned before, it's really easy to interact. I mean, you could take the pointing gesture to decide which lamp you want to interact with, but getting this pointing gesture is really difficult outside the headset. You have to monitor your hand. You have to put it into a relation to your interface you're seeing in the virtual world. Now, at the same time, you look there already, and your eye and the system is very, very defined, so it's very easy to use. So when you think about next generation interfaces, you have the chance to give your users and yourself an edge by using eye tracking. It's easy to use, as mentioned before. It's very efficient. We do that with very large companies like automotive companies that work a lot with CAD workplaces. And they use Nuya, our software, to control or to add another way of controlling into their CAD workplaces, PLM workplaces, everything that's a complex interface. And actually, from our perspective, IDEs are also a complex interface, an interface where you change focus very often. And in these situations, we use eye tracking to make your work easier, and I'm going to show you in a bit how we do that. And the third point is really it gives you completely new possibilities on how to interact. Suddenly, we have a link into the unconscious input. We don't have to wait for a mouse to do something, but we can kind of read the mind of the user, and that goes to the point that if somebody starts searching for an image based on analysis we can do in the background, what patterns, what kind of similarities are in there, we can, out of a data set of 20,000 images, we can filter out like 500 images which probably contain the one you're searching for. So that's how far you go. The user doesn't have to do anything. He's just starting to search, and we automatically understand what he's searching for. So one of the biggest problems you will be facing if you consider eye tracking is that interfaces today are not built for eye tracking. They're built for mouse and the keyboard. And so that's kind of the challenge you will have, and you will have that, or we will have that for a long time, because mouse and keyboard won't go away. There are many situations where you don't have it. You're not always in a virtual world. You're not always having an eye tracker connected. So we have to consider existing interfaces. And the reason why that is difficult is because eye tracking in itself is a very interesting technology. First of all, your eyes does things you don't want to. You don't use it as a pointing device usually. Second point is really your eye is constantly moving. Even this is real-time. This is a real-time image feed. The person was looking at the dot in the middle, and on the screen this would be about the size of a quarter. So the eye is constantly moving every millisecond. What happens in addition is that there is an offset, and that is something that comes from the sensors, that comes from the eyes. It's really hard to exactly pinpoint the point. So even if you do an average and you say, okay, this is the point where you think the user's looking at, in fact, he will be looking something like 1 degree off of that point, and that's something you cannot filter out, you cannot compensate. At least so far, nobody has achieved that. Which brings us to the second problem. Even if you start designing buttons in a size that work with eye tracking, you have to consider that the human eye does not focus the center of a button. The button, or the point the user will actually focus, and that depends on the person, will actually be some point that is interesting in the button. So that changes the way you have to think about how to design your buttons. You shouldn't put anything on the edges of the buttons themselves. So given that, let's revisit how we trigger a button. One of the typical ideas you'll get when you tell somebody about eye tracking is really they'll tell you, can I blink to click something, or can I nod to do that? And actually, we did it in the beginning, so it's not that stupid of an idea, but it just totally does not work. You'll try it. We even got to the point where we could separate conscious and unconscious blinks. But the moment you sit in front of your computer blinking all the time, it's just not an interface. It doesn't work. So second aspect is what happens if you just put a pointer and you use that pointer to actually go to the items you want to interact with. Sounds reasonable, but forgets the offset. The problem is the user is looking at the gray dot here in the middle, and the moment you put the pointer based on the offset you have, you'll put the mouse pointer a little bit off that. Now what happens, and it's funny to see, the moment the user, you give him the mouse cursor, he'll actually look at the mouse cursor. So that changes the position he's looking at, and that changes the mouse cursor. Every time you put somebody in front of an eye tracker with a mouse cursor, they'll drift off in some direction. It's funny to see. So that's not an interaction possibility. And another way that has been around for a long, long time, mainly for people that had to use it hands-free, is a timer where you look at the button and you wait for the timer to trigger, and that was very fast. Anyway, it's annoying. Everybody who's sitting there who wants to get up to speed, he's like waiting for circles to fill. It's a little bit like Kinect, actually. So if you go one step further, one very reasonable approach is if you have situations where you have your hands on the keyboard anyway, it's actually use the keyboard in addition as a secondary input, and suddenly you know when the user wants to interact. That's one way to solve that problem. Not the most elegant, but it's in many situations a very efficient, very fast way to do that. Another way which we use a lot is what we call gaze patterns. What we do is, because users cannot gaze into nothingness, we use additional graphical elements on top of the existing application. So this button with German labeling actually comes from German Outlook. The moment the user wants to trigger that, the moment he's looking at this button, we recognize that, we give him a second. On top of the Outlook, we put a secondary input layer, and the moment he looks at that button, he triggers that. So that's very fast. It's something the eye is very good at, focusing at things. So we have a reasonable interaction, very fast interaction, actually. And then there's something that we are working on a lot in our research, which is trying to predict when the user wants to push a button. We're not there yet. We internally, for us, it's the holy grail, but it's something interesting. So if anybody tries to solve that, we are happy to work together on that. Having that said about buttons, obviously it gets a lot more difficult if you work with drop-down menus where you have several interactions. You have a big problem with lists because everything is active, so it's really hard to select something. You need to put some brain into how to solve that. And same with text, because like every inch of your interface is basically active right now. And many, many more. So stopping at that point with what are the troubles with eye tracking, let's focus on what you can do. And one of the IDEs we have enabled, because we use it internally, is QtCreator. So actually there is a version of Nuya that can be used to control or to add eye tracking interaction to QtCreator. And what I'll show you now is some of the interactions we've done in that, and some of the solutions we've done there. And what you'll always see is the video stream on how we solve that, so that'll repeat. One of the items we're doing is really, we understand where the user's focusing. Now you're debugging or you're coding, and the moment you want to see the debug outputs, I mean, there's shortcuts to do things. The nice thing with eye tracking is you don't need shortcuts anymore. We always, more or less, we use 1.5 keys. It's the right shift key usually. The moment you push that key and you don't push a letter to capitalize something, we know you want to interact with the eye tracker. So the moment you look at one of the panels, you click the right shift key, it'll pull that panel up, and you have the full screen view of the debug output or whatever you want to do. Very convenient to use. Another very interesting point, and that's something I use a lot when reading, actually, last gaze point. We know where you've been looking at last. So when somebody comes in or you turn away to do something else, talk to somebody, we remember where did you look last. And the moment you look back to the screen, we put a little visual indicator to the point where you've been working last, the line of code or whatever. Now, that might be disturbing in a non-eye tracking world, but in an eye tracking world, the moment you look at that indicator, it disappears. So you can immediately pick up working wherever you stopped or where you looked last. Another item, and then that's very, I mean, everybody who's familiar with eye tracking has come across that, but it's really nice to use because especially if you read your emails or you read sort of longer documentation, stuff like that, you just sit there, you have a cup of tea in your hand, a cup of coffee in your hand, and it just automatically adjusts to where you read. And the interesting thing is, here it might look like it's jumping, but when you read, it's completely adjusted to you, and it'll be exactly at the point where you want to read. Then we have the gaze buttons. That's the concept I've been showing you before, and that is something we just kind of plug into a QtCreator. We do that in Nuya. Basically runs as a middle layer with graphical elements that runs on top of QtCreator. So the moment you look at functions you have defined you want to access quickly, like for example the build button or something, the moment you look there, you'll get the button. You just have to look at the second gaze item, and you're there, and it starts to compile your applications. List selection, very similar concept. That was very interesting for us to solve because you have so many items so close together. So how do you figure out which item do you want? And the easiest way is really take the ones that are closest to where you look, give a gaze selector for every one, and you just go there, and there you have it. App switching. In this situation, actually, the situation you're seeing here with the 6 windows, it's quite simple. I mean, that's maximum 5 Alt tabs if you want to go there. I'm sure you've all done that move quite a lot of times when using a computer. With eye tracking, you click Alt tab, look at the window you want to have, release Alt tab, and you're there. And just, I mean, I'm one of these persons that usually has like 20 different open windows, and it's really convenient. It's something you don't want to miss once you've tried it. Okay, Geistlich. That is something, you always come to the situation where you have not prepared every button that comes up in an interface. And in that situation, it's very good to provide the user with a default opportunity. So in that situation, one of the things, or how we solved it, and which works quite well from our perspective, we give a short indicator on where you were clicking. So the moment you push the key, the right shift key again, you get a small indicator on where you have been looking, and based on that you could readjust, which is a really convenient way to even go into text. So you click, you might not be at the right spot at the first moment, either you use the cursor keys to get there, or you just give it a second click because now you know what your offset is and you can go there directly. Another feature is active corners. There's some functionality that you'll be using very frequently. You know that from other operating systems where you basically have some functionality put to the corners. We basically did the same with gaze. So the moment you look at one of the corners of your computer, of your monitor, that will actually be recognized and will pull up some special functionality which you have defined or configured to come from that point. And then the one feature which I personally like the most is directed search. One of the things you do very frequently is search for things, obviously. When you search for an item in your code, when you search for a file in the overview. So to search there, you either go to the different windows, but you click into the different windows and click Control F. Now what you do, just look there, click Control F, and you're searching in the area where you want to search, which is a reasonable way to do if we have eye tracking to understand what you want to do. These features are not only available in Qt Creator, but can be used in any application, and it is something that if you want to use these kind of features in applications you're doing, please contact us, because there's a whole framework we can offer where we have best practice approaches from our experience. The market is just developing right now, and we believe one of the key features will be to have uniform, to have similar concepts when using things. And for sure we don't say we have find the golden solution for every single approach we have, but it's a really good solution to start from there, or to have discussions and integrate it into one kind of interface. One last thing to look at, and that's something where we go into the last point. We have a totally new kind of information to work with. Now, this is something where the user does not see the interaction. He does not do, or he can do different things with eye tracking, but suddenly he's sitting in front of his computer, he's looking at his code, or in that case, we did that for a financial company. He's looking at charts, information, and the way he's looking at things is basically unreadable. It's really, we try to analyze, understanding what is interesting. It's really difficult with today's eye trackers. Now, the interesting thing is, what happens if you run the same software on a group of people? You have a work group of people that is looking into things, and suddenly you are able to understand similarities in the things that are happening across the people in this work group. And you might recognize, okay, there's a piece of news, there's a piece of information, there's a piece of code people very often visit, or take a long time to go through that code because maybe it's not that well written from the first place, or things like that. The moment you see that, and you know, okay, there's a piece of information somebody else has not seen, you actually know which person in the work group have seen the information and which have not seen the information. And now you go back to the visual cues and just tell the person, hey, have a look. The moment the person has to look at the information and ignores it, you know, okay, fine, nothing to do here. And suddenly you can first of all train people faster. That's something in the beginning people tend to oversee the important things or focus too much time on things that are actually trivial in the end. You can coordinate across your team because you can make sure that everybody has looked at the piece of information that you want them to look at. And you can improve people and the whole software all the time because you understand which areas might create problems, where many people are stuck a long time, then you know you have to look into this. And the nice thing is eye tracking goes to the point that you actually can understand if people are lost. For example, they are somewhere searching for the checkout button in an e-commerce store. The moment they search for that, there's a pattern. The patterns change how they look around, and you could use that information, and based on where they are in the process, you can tell them, hey, here, by the way, that's where the checkout button is. Maybe you want to go there. Yeah, so these are some of the things you can do with eye tracking. We're getting to the end of the session. If you want to try eye tracking for yourself, you have to get one of these eye trackers. We work a lot with Tobii eye trackers. There's like 3 or 4 companies that sell them. As I said, it's like around about $100, and I truly believe it's something people that develop interfaces have to look into for the next generation of devices. If you want to use it for yourself, we have done a special promotion for QtWorld. So yeah, I see people taking the cameras out. Feel free to take a picture, use QtWorld. Until 31st of October, you'll be able to get Qt at a 42% discount, obviously with the name of the company. You can see the IDE booster on YouTube to get an idea of the features you've seen here. And if you want to develop in that area, please feel free to contact us. It's really something that is just starting. The penetration of devices is still low, but it will increase rapidly. And it's a very close collaborating community. So just get in contact and we'll see what we can do together or how we can help you. Not to go into the same pitfalls we went through. So far, thank you for your attention. And yeah, if there are any questions or anything, feel free. Good.
All right, thank you very much. Any questions for Tora?
What if the eyes don't track, like somebody has a wandering eye or something like that?
That is something that is mainly compensated. When you use eye tracking, you have a calibration at the beginning, and depending on how steady this wandering eye is, and I don't know that much about it, but you can try it. I mean, I have a demo set up here. You can try it, and then you'll know if it works. But it works with glasses. It works with contact lenses. It works with most typical, like, yeah, works. No, actually I don't. I have it with me in my suit over there, so just come up to me. I can show it to you.
What about multiple monitors?
We all work with multiple monitors. The pity is that eye tracking only works on one of the monitors, but that doesn't matter. I mean, on that you have full control, but what we also do, the moment you look to the other monitor, we, for example, remember the last mouse position on that monitor and send you there again, and stuff like that. And also, if you lose the mouse, for example, you'll get it, or you can move your cursor and you get the mouse to that point. So yes, it works.
Is it some specific hardware or any webcam or stuff like that would
work?
No,
it's not a webcam. It's as I said, it's these kind of sensors, or that's one of the sensors we're using. It actually has in that sensor, I think, 2 cameras and 3 LEDs, and it needs reflection in your eyes. It's infrared, so don't see it.
So, do you have an SDK that is usable? Is that what is based on Qt, or the purpose of the Qt usage here was the integration in Qt Creator? Like, what about a standalone SDK based or not on Qt that could be integrated in other Qt apps?
The Qt Creator is actually just one of the apps we have. We have written it completely in Qt, and we have an SDK that we use internally. We are now in the process of giving it to other developers. So if you're interested, let us know. That's what I mentioned before. And we'll make it available. It's not completely, I would call it like alpha.
So what is the sampling rate from the camera that's looking for your eye? And then when it processes, does it have a reduced rate of where it believes you're actually looking?
First question is, sampling typically happens around 60 hertz with standard eye trackers. That's why we cannot do some of the things that you can do with 300 hertz, where you see a lot more smaller movements. With regard to do we reduce this, we actually, NUYA has several rolling averages, different things running all the time in the background, and we use that to try to understand what's actually happening and what the user intention is.
Okay, we have time for one more question.
Can you talk a little bit about the hardware specification of like what kind of cameras, and you said LEDs, and also like how do you like fix it to your laptop or your monitor?
Well, the thing is, the only thing you need, well, you needed USB 3. I think they went down to USB 2 again. I'm not sure. That's the only thing you need. You can run it on, I mean, any. It's you fix it to the bottom of your monitor. The bottom, because if you do it on the top, very often your eyes are shaded. You put it on the bottom. There's a little area here with 2 magnets, and you have a little metal plate on your laptop. So it's really, you put it on, click, it's there, and you need the USB connection. Sorry? In there, we are not doing the sensors itself. Our focus is the software, so I don't know the specification of the sensors, except if you're trying to build an eye tracker for yourself. Go to SMI, go to Tobii, buy one for $100 and you're set. It's a little bit like the times when the first webcams appeared on the top of the PC.
All right, we've got to wrap things up for now. So thank you very much, Tora, and thanks for your time and attention. Enjoy the rest of the World Summit.